Just got to make sure I don't overheat here. Yeah. Okay. So, hi, I'm Ian. I was kind of an applied math dude for a bit, and now I just kind of squander. Um, I guess I'm chronically unemployed. There needs to be a better label for that, like employee cell or job cell or something like that. But, anyways, that's me. And I do these things, or at least volunteer, because I am horrible at presentations and talking to people in general. So I'm kind of embracing the growth mindset. And as Ted said, it's a good opportunity. So anybody who's waiting on that chance, go for it. Should I do the share screen, or are you gonna manage privileges and all that?
You're
Okay.
muted, Ted, but
should
you
be all
can go ahead.
you should be all set to share screen.
Okay. Boop, 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 boop. Share. Been a while since I've done this. All right. Can you see my screen?
Yep,
All
you
good?
can.
All right. So, I just want to start with the disclaimer. Some of the examples get a little bit repetitive. They tend to have the first kind of two lines. And generally from the relevant line that's changed with the clause, you can kind of suss out, what columns what they're trying to ask for. So after a while, I kind of just drop the select and the from, just for brevity. So chapter 4, filtering data. This and chapter 5 are all about basically filtering and distilling down to the rows the data that you want. That's very important because usually if in a production situation with a humongous database, you're not just going to go select star and get gigs of stuff back. That's not really useful. You're usually looking for particular information, subsets, subgroups, things like that, and hoping to aggregate and do a little bit of basic stats. So at first they introduced the where clause, and that comes after the from. And they give us this basic example, from the products table, select the product name, product price, where product price equals to 3.49. But all the other logical and comparison operators work. We see here we got inequality check, inequality less than, greater than, whatnot like that. There was a note about the fact that there's kind of multiple syntax for non-matches, not equal to, and I tend not to see this little wonky double bracket thing too much. I think this is more intuitive, because the exclamation point tends to represent like negation or not, and the equals, so it kind of like strings together and looks more, you can kind of like say it out. I also thought that this was kind of a potential point to trip up for other people who are maybe like learning Python or JavaScript, or maybe even C or C++, Java, whatever. Most major languages, they're going to use the equal sign for the assignment operator and the double equal for comparison. So it's kind of a one of the many quirks of SQL. So the author brings up kind of a good point about actually kind of using a SQL database in a system, and he mentions that you can essentially query a database from a client, whether that be like the back end of a web page, and you could ask for all the data and then filter it with your client code. But that's just a horrible idea. It's not a good practice. And if you were to do something like that, just request all the data, then filter in the client, you'd be wasting bandwidth, because you're basically saying, grab me all the data from wherever. It bogs down the client, and then of course you have to have all that excess code within the client as well. And the author brings up this point that we've kind of hit before, I think in the last meeting, that databases have been around for decades. So all the major vendors, they've highly optimized the database management systems for doing the operations that most people do and doing them very efficiently. So not only does this include filtering, but it includes joins, which we'll see later, and sorting, which I think we saw last session. Then the author kind of restates where the where clause go, where the where clause goes in the sequence, the order of clauses, and that the order by comes after the where. And one thing I've done in the past, at least when I was learning SQL, I think the first time, I've kind of gone through this like a bunch of times, is I've done a general search for SQL order of clauses or order of operations, and you'll generally see like a lot of images that feature kind of a flow chart or 7 or 8 different clauses in their natural ordering. Because it's useful, because although we only have a few clauses right now, 4 or 5 if you have a limit or top, eventually you're going to have joins, you're going to have other things, and it could be good for reference. Another important note, the author kind of tells us when to use quotes, when not to use quotes. So in SQL and I guess a lot of other programming languages, we do use quotes for string data, anything like a string literal. And that also includes SQL's, char, varchar, or even enum data types. Interestingly enough, I guess this is more of a spoiler. We do use single quotes for datetime objects. That was a little bit funky to me, but I guess it makes sense now. We'll see that in the future. And we do not use quotes for numeric data types. There is kind of a distinction between single quotes and double quotes. They're kind of not the same. A lot of languages will have sort of different purposes for those things. Double quotes have always usually been used for encapsulating strings that have single quotes in them. We're not saying large strings now, but supposing you have a varchar or a blob data type, and it's like a sentence, a normal sentence out of a book or something like that, and it has single quotes. In order for that not to be parsed and confusing for the DBMS, we would encapsulate those in double quotes. And you might see double quotes in other situations, more advanced situations as well. So then the author gives us the between operator, and that's for querying ranges. The important bit about this is that the interval endpoints are inclusive. You always got to check those things, because, for example, in Python, ranges and other things in other languages, one endpoint may not be included, and it's definitely good to know that. Basic syntax is, where the column name between value 1, value 2. Pretty self-explanatory. It is essentially syntactic sugar. We're not the author hasn't introduced the or clause, but you'll eventually see that you could accomplish the same thing with less than or equal to and greater than and equal to statement. But it's there for us, and it's nice. It's good. It makes it easier to read. The author doesn't really mention this at the moment, but it might be something that comes up later. There are a few kind of gotchas, kind of weird bits when it comes to using the between operator. The between operator implies that there is some way to compare the two arguments in a way that makes sense. And it turns out when it comes to comparing strings, there may be a variety of string comparison functions. I mean, we have lexicographical by default, but some people may assume or want alphanumeric or any other variants of that. And after working with this for a little while, you'll kind of find that there are a lot of threads on Stack Overflow and other forums where people are going like, okay, I queried my data like this, but I expected or wanted it to be like this other form. Why is that? And so it's one of those implicit things that you kind of have to, double check that it's doing what you want it to do and work around it if it's not. Here's the basic example. Just with a numeric type, if you're querying any kind of product from the products table with product price between 5 and 10, nothing too surprising there. And then next, the author introduces nulls. SQL has a null type, doesn't really have a nan, not a number type. It doesn't really have any other varieties of those sorts of objects or tokens you might see in other languages. We just get the null. And a null is essentially a no value. It's not zero, because 0 is a valid integer. It's not an empty string or not just spaces. Is literally there is no value. It is missing. And like a lot of other things in SQL, there's some little particular points about this. You might want to ordinarily check if something is null, like, if there's missing things in a, products that are missing prices, you might be tempted to use the equal null in your where statement. But that's not what we do. SQL has its own, separate clauses for checking that. And here we have is null. That's how you check that. And by extension, we also have a is not null. Another particular point here to keep in mind is that null values are not included when filtering for matches or non-matches. And you'll see that by extension with other aggregate functions, average, count, things like that. They're if you count up all the product prices, and one of them has a null or two of them have a null, those will not be included. And that's good to keep in mind. And this example, it's not too interesting, but it is just a reminder that you can query a column name from a table while simultaneously having a condition on a different column. Here we're getting customer names from the customers table, but what we're really checking for is all customer names, customer entries for which the customer email is missing. And that's a pretty standard usage. The author makes another point about a lot of database management systems and vendors, they have their own sort of extension functions for working with null values, checking null values. And for that, you have to look at the documentation and be sure what's available or what you think is available is actually available. One observation I kind of made after working with these things for a little bit is that despite some variance in null checking functions between the databases, a lot of them have at least a coalesce, and that's something we'll see later. And I mean, that's sort of lesson 4. Did anybody have any particular questions or any hangups or points of confusion while reading the material? Oh, we got some chat.
Yeah, no real questions for you, just a few side comments.
Oh, yeah.
I'm going to add a little bit of color to what you talked about.
Mhm.
So you mentioned that like, hey, I can say select customer name, and I can use the where clause that has a different column, like customer email is null. And so I'm just going to extend that, and I can say you can always have any where clause that looks at anything, and it's completely independent of what you're selecting. So you can say select first name, where last name is this, and birth date is that, and customer email is this, and da 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 da, and none of the things in your where clause need to be in your select that's returned. Now, behind the scenes, it does mean that the database needs to fetch all of those things so that it actually calculate your logic. But at the end of the day, once it's done doing all that logic, it's going to throw those away, and it's only going to return you the things that you asked for. So very much that's true. The other thing I just wanted to mention is people may have, like you mentioned, had some kind of NAs or not a numbers in a language like R or Python. And so if you have experience with this, then you'll probably find nulls to be pretty similar. But if you don't have experience with this, the thing you need to know about nulls is that because they're considered not a valid answer, so to speak, it means that if you do anything with them, then it tends to result in not a valid answer. So if I said I would like to add whatever, husband's age plus wife's age, two different columns, husband age and wife age, okay? If husband age is a valid number and it's 25, and wife age is null, the sum of those two will be null. The null's just going to gobble up that 25 and it's going to disappear. And pretty much anything you do with a null. So if you have a where clause and you say if husband age equals wife age, if one of those is null, then it will be false. What might be surprising to people is if both of them are null, it will also be false, because is not a valid answer does not equal is not a valid answer. They're not numbers. They're just is not an answer. And so those are the properties that I think, again, many people who've worked with those will experience it. But if this is new to you, just know that you have to be very careful. It's possible in some tables you will not see any nulls whatsoever. And it's possible in other situations you will, and then you just need to be very careful if you're doing any logic to, in either your filter, your where clause, or any arithmetic or anything like that with it. You just have to be very careful, make sure that you aren't accidentally either omitting the things that have nulls when you really wanted to include them, or that you're not accidentally clobbering things. I find it very annoying if, like, I say something like first name concatenated with middle name concatenated with last name, and if the middle name's null, then I get no name whatsoever. So little things like that are kind of annoying.
And I guess that's why, they didn't introduce it now, but eventually I imagine there will be some kind of topic on cleaning and sanitizing data and replacing nulls with valid tokens, for which, logic then makes sense.
Yeah, I haven't read ahead, but this book is pretty concise to give you just kind of the nuts and bolts of writing queries. It's really not about being a data person. It doesn't talk about performance or any of those kinds of things. So we'll see how much of that gets covered. And again, this is a good thing. Like, ask questions if you guys have questions, if you've seen things, and then we can kind of fill in on some of these other topics.
When it comes to things like nulls and edge cases and little quirks that initially don't make sense, like logic with things that don't exist, usually when you ask these questions and you go, why is it that, or why is this defined like that? It's just like math. Usually the definition is a result of needing consistency within the system, within, the logical operators. That's usually what it comes down to.
Cool. Thanks, Ian.
Let's see. Moving on, advanced data filtering. So this is just doing more stuff in the where clause. We get an and an or operator, and eventually we get an in and a not. The author had their own little table but I liked the one from SQL Bolts a little bit better. So this is just a kind of review and preview of what we're getting in our where clause, the different things we can do to filter. Our logical operators are between, as we've seen. Note it does need the and to separate the two arguments. And we're going to see an in and a not in. So first up, we get the and operator. So you know, in that, what it does is that when used with the where clause, it will return rows that match both conditions, you know, just like you would kind of imagine. And it's just to, you know, further distill searching, you know, get a little bit more specific. The syntax is as such. We got condition 1, condition 2, and we got an and. They give us a basic example. You know, vendor ID equals whatever that arbitrary code is, and product price less than or equal to 4, and it'll spit out the appropriate rows. These things, the ands, can be daisy chained, a kind of point that I think was neglected was that, you know, when it comes to chaining ands and ors and, you know, all the further filtering, it's usually typical to see everything kind of laid out on separate lines rather than, you know, one big gigantic line. It's just easier for readability and you know, changing code and maintaining things. And then we have the or operator. And the or operator works, you know, how you would expect it to work from other programming languages. It's a logical or operator. So it will return if one condition is true or if both conditions are true. So what that means is that it short circuits. You know, the database will evaluate the first condition, and if it's satisfied, it'll automatically just, you know, include that and do further processing on it. It doesn't check both at the same time or anything like that. It has to do, you know, one then the other. You know, the or, which people, you know, might intend from the English language, is usually the exclusive or. That's just a, you know, a little difference you'll see in computer sciencey topics. So we have a basic example. You know, we have one condition separated with or and another condition. And nothing too surprising about that. The author gives some advice for, you know, chaining multiple conditions. And there is an order of precedence. You know, and operators are evaluated before or operators. SQL does support parentheses to, you know, kind of make your queries more explicit, and also to, you know, ensure that the order of evaluation is as you intended. Parentheses have a higher order of evaluation than ands and ors. So with those points in mind, the author gives two example queries. And, you know, one has the parentheses and the other doesn't. If you look at this first one, it will evaluate the and first, and then evaluate the or. And, you know, in the book, it spits out about, you know, 5 rows or something like that. The alternate is, you know, you encapsulate the or with parentheses to ensure that that's evaluated first, then the and clause is evaluated. And in that example, it spits out like 1 row. So that's just important to know when working with these things. Then the author introduces the in operator. And the in operator essentially takes a comma delimited list of values that you want to check against. And these are you know, essentially valid values you would otherwise use in an or statement. So what that really means is that the in operator is basically equivalent in most cases to just a sequence of or statements. You see here that these are equivalent. So we got two valid values, same two valid values separated by an or. Those conditions will result in the same thing. But why does it even exist? Why is it there? Well, it's kind of mostly to make things a little more manageable when filtering and specifying, working with lots of conditions. Imagine you were in a situation when, you know, you wanted to check a certain value against a whole ton of values. Would you rather have an in, or would you rather have the equivalent pages and pages of or statements? Most people would prefer the in operator. The author provides a little bit more insight in that the in operator executes more quickly than lists or operators most of the time. You won't notice that with small queries, but for very large queries, you know, that could be noticeable. And although the in has its equivalent in or statements, there is actually something that distinguishes it, in that, you know, eventually we'll see that the in operator can actually contain a select statement. So it allows you to kind of get a lot more advanced with your filtering in where clauses. But that's not super important right now. Then we get the not operator. And that works exactly how you would suspect. It negates the following condition. We note that the syntax is we use that before the condition. And again, it's most of the time it can it's just kind of syntactic sugar. It's not, you know, there's an equivalent, you know, non-member equivalent statement with our normal comparison operators. But you know, why we get it, you know, it works well in conjunction with the in operator and other situations. It's just kind of a nice thing to have. And I think that was about it for lesson 5. Most of these operators are, you know, fairly intuitive. You just got to be careful of a few little weird bits. Did anybody have any questions, points of confusion? I'll see you. We got a question in chat.
So for people reading along in the book, I don't know if you're looking at the sort of challenge questions at the end of each chapter or lesson, as I guess they're called in the book. I think we're still in the very early stages of this, and so the challenge questions probably seem pretty straightforward. But I do encourage people to do them for 2 reasons. One is for the practice, because right, like something you hear only once, oftentimes it doesn't go into long-term memory. You know, a few repetitions and that helps transfer it from short-term to long-term memory. But also when we get to a couple of the you know, more complicated sections with joins and things like that, you may actually think you know the answer, and then if you actually run it, you may see that you're getting slightly different results than what you meant, because there's some trickiness, you know, there's some subtlety going on. I did also look, and Ian, you mentioned SQL Bolt. So like SQL Bolt has a few sections on filtering, and you can go on there. They have their examples, and you can try running the queries there. It starts with the what is it? Select queries with constraints. Yeah, part 1. So there's like 2 or 3 sections in it. If you scroll down after the explanation, you'll see that they have a place where you can actually type your queries and you can test them out. So they have 4 tasks on the right, and you get to try writing a query and see if you can get it to do, you know, what you want. And then also SQL Zoo has a couple sections on filtering also, what they call their select basics. And so you can try running your queries there. Is there a button if you scroll down? Yeah. Or
You know, it just kind of auto-evaluated,
oh
actually.
wow, it's like
Yeah,
instant.
it was like, hey, this is a
watching your
valid query.
cool. Let's see here. So anybody else have any questions or comments? Yeah, SQLZoo.net. Let me. This is specifically the one on like where clauses.
Oh, it's got that old school wiki look to it.
That's actually if you look at the URL, SQLZoo.net/wiki.
Oh yeah.
But that's one of the things I liked about it is it's like I'm not actually getting an aneurysm from the ads that are at the top, the bottom, the left, the right, the pop up, the autoplay videos, and all these other things. It
I see
reminds
that.
me of the movie that they made out of Ready Player One. You know, the bad guy says something, you know, they have the VR headsets and he's like, yes, we've discovered we can cover, you know, 84% of the visual field with ads before inducing seizures, something like that.
I recently got a Pi-hole up and running. It's a DNS filter. So it's, you know, it'll kind of cover a little bit of base that, you know, maybe your normal ad block extension doesn't. But
Okay.
it takes a little bit of load off of it. And it's got a nice front end that you can see. You can see, you know, how many queries and from what domains that it's blocking and like that.
Yeah. Yeah, it's nuts. If you just look at a regular old web page, it might do hundreds, if not thousands of requests
tons.
just to load one darn page.
You know, you can actually use it to kind of suss out what on your network is reaching outward. You know, a lot of people have found that, for example, you know, when they looked at the dashboard, the analytics and the logs, they've been like, hey, wait, my Samsung TV is reaching out all the time, or my refrigerator is reaching out all the time. And you could be going like, what the heck?
Yep. Okay. So any other questions, thoughts about the filtering content for today?
Well, just an observation I noticed between using the expression not versus the less than and the greater operand, and like the exclamation point and equal. It's like when you use the word not, it comes first before your column of reference. But then when you use the other expressions, it comes after the column. So that's something I have to keep in mind.
Yeah. In some languages, there's like a not operator. And it's a little bit different in SQL. In SQL, it's really just how do I say it? It mostly will reverse an expression that's true or false, but you can't like put not in front of an equal. You can only put not in front of like a true or a false kind of expression. So thanks, Sule. That's a good gotcha. I hope people aren't quizzing sort of just on like syntax, but yeah, that'll trip you up if you're putting nots in the wrong place.
I had a quick question about the OR operator. So for example, if we have a year column, a bunch of other columns as well, and we're trying to filter the where clause by the year column, and we have, say, year 97 a few rows, year 98 few rows, and maybe 99 few rows as well. And if we do where year equals 97 or year equals 98, does that mean you just get the 97 because it executed true and it wouldn't pull the where equals 98?
It will pull those because if it will evaluate the or year equals 98. So it'll check independently, and if the first condition is false, it will check the second condition, and if the second condition is true, that satisfies a logical OR operator.
Right. So what Ian was saying about short circuiting is if the first thing is true, then it doesn't really need to look at the second thing. But for rows where it's 98, the first thing isn't true in your example. Okay. Does that make sense as the basic answer?
I meant if they were true, if where year was equals 97 or year equals 98, and there are rows with 97 and 98.
So okay, so let me actually give the fuller answer, because I think that might actually help you, because this idea of short circuiting, maybe there's places where the implementation does it, but for the most part, it's not guaranteed, and it's probably not useful to think about short circuiting. Okay, so going back to 2 weeks ago, what I said is SQL is a declarative language where you tell it the properties of the rows and columns that you want returned. Okay, and if you get a little bit more technical, what it's really doing is it's doing set operations. Okay, so find the set of rows where I forget what we said, year equals 97.
Right.
Find the set of rows where year equals 98, and do a set union, because that's what OR means, of those two, which will not create duplicates. A union will, so even if something matches in both, you'll still only get one when you do the union. That's what conceptually your database engine is trying to do for you. Now, it may not actually do it in that manner, but that is the result that it is trying to achieve for you. Okay. If you think about it the way I just said it, it's kind of really hard for the database engine to ever know that I will never need to check to see if the year equals 98, because the year equals 97 is always true and can short circuit it, because it's not doing it one row at a time. It's actually calculating giant sets and sort of doing it. Okay. We can get into all sorts of really weird examples. I would say that I have never counted on short circuiting, but it definitely comes up at times, because I will do something like convert some string that has the year into an integer, but somewhere in my table there's a bad value that's not actually a string with digits. It has some garbage in it, like letters. Okay, and I've had cases where I run a query and it runs perfectly fine because it just happens not to hit that thing. And so like the short circuiting behavior is sort of happening. But then there's other times where I hit that particular row and I get a big fat error message because it said, you can't convert, XXX to an integer. So at least personally, I find that I have to be aware that short circuiting might happen so that I can understand why sometimes it'll error and sometimes it won't. But generally speaking, I don't ever count on that behavior. So that was sort of the long answer. Does that help?
Yes, thank you.
I think it's relevant in terms of, if you learn and you mind map, you're going to be looking for similarities, commonalities with other things. And that's why I thought it was relevant, is just because it's the same kind of operation you'll see in actual programming languages. So even though SQL is declarative, you'll see that behavior elsewhere.
Yeah.
Gotcha.
Yeah.
Thank you.
Cool. Any other questions?
Yeah, so I got a quick question with nulls. What's the when you do a count, do the nulls get included in that count? I think I remember from the chapter that
the nulls do not. If you
Okay.
want to count nulls, I think you have to use an exists clause. It's something else. But yeah,
Okay.
usually when you count up or aggregate via by a column that has null values, the nulls will not be included.
And what about like when you just run something and it tells you the number of rows at the bottom?
That's how many rows got returned to you. So that's just a convenient thing so you can see how much.
Is that including the nulls too?
Yes, it is how many physical rows were returned to you regardless of their contents.
Okay.
Okay. So, in the book, we're just doing toy examples. So often you'll see like 2 rows returned, 3 rows returned. But if I get a screen full, it's kind of hard to tell. Did I get 40? Did I get 50? Did I whatever? It's convenient just for it to see like the actual number. And I can turn that off if I don't want it. I can have it, not do that. But one of the things I do when I'm debugging actually is I will run a portion of a query, and I'll say, oh, this portion of the query, there's 101 people. And so if I'm supposed to return like the sum of of how much money they've ordered things, I better get 101 rows back. And oftentimes I don't, because there's something wrong with my query, like some nulls somewhere sneaking in that are breaking something. And so, oftentimes I use that feature, Harold, where I see, I ran this little snippet and there's 101 people. And so now I run this other snippet and it gives me the totals, but now there's only, 95 people. And so I know that somewhere I lost 6 rows. I did something wrong.
We haven't gotten to that part where you can just run a portion in the book, have we?
I don't necessarily mean running a portion. I mean, I just literally use a smaller query that's like a portion of the logic.
Okay.
And so I say, how many people are there? It's 101. And then I run my real query where I'm trying to, add up something for all the people. And then I realize, hey, something's wrong. I'm not getting the same number of people.
Okay.
And eventually you'll see you can actually go in the other direction too. You can get duplicates. You didn't write your query right. It's like, wait, I have 202 answers returned. I only wanted 101. What's going on?
I believe
Cool.
SQL has its own another little syntax for counting rows. You can do count star, and it will return the appropriate number of rows and I think in the background, what it's really doing is just counting how many, valid values there are in the primary key, which is guaranteed not to be null by constraint on most tables,
Yeah, we'll get to that. There actually is like a gotcha with count star. And so I actually use a very bizarre looking syntax. I use count 1.
Yeah, I've seen that one too.
So select count. And then if you say count 1, then basically for every row, it's going to include 1 and it's going to, add it up. And it's guaranteed that you will never not count a row because 1's just a literal constant.
I would almost suspect that the 1 is a placeholder. Like, you remember that kind of not so explicit sort syntax when you could be like, give us, sort by column 2 and column 3 rather than their exact names. Do you think it's really doing some kind of algebra, or not algebra, but arithmetic with the count 1?
So actually for count, no, it just needs to know that it's a non-null value. If I said sum 1, then it would literally be adding up all the 1s. But yeah, so you're right. Count doesn't really care what's in it as long as it's not null. So I think like if you did select star and literally the row was all nulls, then I think it wouldn't count it or something bizarre like that. And then there's poor implementations that a select star will run slower. Generally speaking, like Oracle SQL Server, you expect it to be optimized because that's the old-fashioned way that people did it. They did select star, but I'm sorry, count star. We haven't even got to count yet, I don't think. But anyway.
Yeah, sorry, I didn't mean to jump ahead.
No. These are good questions, and again, sometimes it's helpful to hear things multiple times. But so yes, so that there is a function called count is not very interesting. Unfortunately, there's actually quite a few gotchas in SQL when you're trying to count things. And so it will turn out that counting is actually a meatier topic. It's not just one sentence or one paragraph. I haven't looked in the book to see how he covers it, but in general, it's surprisingly, it's not just a one paragraph topic.
Can you count any other number like 0 or 5?
Usually the syntax is select count a certain column name. Okay. And basically the question that was asked before is, will it skip nulls? Yes, it will skip nulls. If you don't want that behavior, then oftentimes what you really want is just something like count 1, which means just count every row regardless of what's in it. Does that make sense, Maya?
Yes, I understand that count 1 is better. It just I was curious what will happen if I will use other number.
if you say count middle name, okay, and there's 100 people, but 20 of them have null as their middle name, the answer will be 80. So even though there's 100 rows, you will get 80 as your count.
Okay, but I know that we can select, for example, one, and it will mean that we get one for each row, right?
It will return a column with the value 1 in it.
Yes.
So we haven't really talked about it, but you can use literals. So for example, I don't even remember what the tables were called, products or whatever. But I could write a command like select head, comma, 1, comma, San Diego from products. Okay. And if there are 100 rows in products, it won't use any of the information in products, and it will literally just return 3 columns with, if products has 100 rows, it'll return 100 rows with 3 columns, and the first column will contain Ted 100 times. The second column will contain 1 100 times, and the third column will contain San Diego 100 times. You don't have to actually return data from the table. You can actually just create your own literals and insert them in various places. So really, that's what select count 1 is doing. It's selecting a brand new literal column that you've created that is always populated with the value 1. And since it's always 1, it's never null, and therefore it will count every row. Oh, I didn't hit enter. I'm sorry. It's like talking when I'm muted. Got $1 for every time I did that. Does that make sense, Maya?
Yes.
So, and again, we are getting ahead of ourselves in some places, but I think that's okay. These side topics, you don't have to understand everything right now. Oftentimes we'll get to the relevant chapter, and then things will make sense. But again, I think there's this like parenting philosophy that says, like, if the child is old enough to ask the question, that usually means that they're old enough to want an answer, right? To get an answer. So in this case, if you guys are, curious enough to like think about these questions, then I think it's reasonable to answer them, just knowing that, well, we still haven't learned everything, so maybe it'll make more sense. But I prefer that to just sort of saying, well, I'm not going to answer that. Wait until we get to chapter 9, and then we'll answer it. I'm not a huge fan of just saying wait.
Yeah, I appreciate it.
Okay, well, we're at time. I'm not in a super rush. If there are any other questions, I don't mind hanging out, but I think we'll sort of formally end the session and the recording here. Thank you, Ian. And once again, thanks for volunteering.
Thanks, Ian.
And yeah, good job.